If you've ever cracked open any electronic device, you've definitely seen them. Those tiny little components with the colorful stripes soldered all over the circuit board. They're called resistors, and trust me, they're everywhere. But what in the world do they actually do? Well, let's dive in and find out.
So yeah, today we're going to pull back the curtain on this super common but kind of mysterious little building block of electronics. We're going to figure out what they are, how they work, and, this is the fun part, how to read that secret code that's hidden in those colored stripes.
Okay, so first things first, what exactly is a resistor? And that subtitle right there, the traffic cops of electronics, that's actually a perfect way to think about them. They're all about controlling the flow.
So the official definition is that it's a passive component, which really just means it doesn't need its own power source to do its job. Its entire purpose in life is to create electrical resistance, basically to slow down or restrict the flow of current. And we measure that restriction in a unit called ohms. The best way to wrap your head around this is the classic water hose analogy. Imagine electricity is just water flowing through a hose. A resistor, that's like you pinching the hose. You're not stopping the water completely, but you're making it a lot harder for it to get through. The more you pinch, the higher the resistance. Simple as that. And this whole dance between voltage, current, and resistance, it's all governed by one incredibly elegant and powerful little formula, Ohm's law. V equals IR. Voltage equals current times resistance. This is like the golden rule for circuits. It tells us exactly how these three things are connected. But here's the thing. Not all resistors look like that tiny, striped component we've been talking about. It's a whole family, really. And each member has a slightly different job to do. So, you've got your standard fixed-value resistors. Those are the ones we see most often. They have one job, one resistance value, and that's it. But you've also definitely used variable ones. You know them as potentiometers, every time you turn a volume knob or slide a light dimmer. And then, to save space, you've got resistor networks, which are basically a bunch of resistors all bundled up into one neat little package. And the stuff they're made of? Oh, that makes a huge difference in how they perform. You can see here, each material has its own specialty. Metal film is kind of your go-to all-around workhorse. But if you need to handle a lot of power, you'd probably reach for a Wirewound resistor. And for something that gets really hot, metal oxide is the way to go.
Okay, let's get to the fun part, the part you've probably been waiting for. How in the world do you crack that secret code? How do you look at one of these things and just know its value?
It all comes down to those color bands. I know, it might look like random decoration, but it's not. It's a language. And once you learn it, you can tell exactly what that resistor does just by looking at it. For the most common 4-band resistor, here's the system. It's super simple, I promise. First, you find the band that's gold or silver. That's called the tolerance band, and you put that on the right side. Then you just read from left to right. The first two color bands give you the first two numbers of the value. The third band tells you how many zeros to tack on at the end. And that last band, the gold or silver one, that just tells you how accurate the resistor is. All right, you ready? Let's try one out. Let's say we've got a resistor right here, and its colors are brown, black, orange, and gold. Now remember the rules. That gold band tells us which way to hold it, so that one goes on the right. Okay, so brown means 1, black is 0. That gives us our first two numbers, 10. Then the third band, orange, that's our multiplier. It means times 1,000, or put simply, add 3 zeros. So that's 10 with 3 zeros, which is 10,000 ohms, or 10 kilo ohms. And the gold band tells us the true value is within 5% of that. See? It's pretty amazing how much info is packed into a few stripes. But what about all the super tiny electronics today? There's no space for stripes on those little guys. That's where surface mount, or SMD resistors come in. They use a number code, but the logic is pretty much the same. A 3-digit code like 471, that means 47 with 1 0 behind it, 470 ohms. The systems get a little more complex for higher precision parts, but the idea of value and a multiplier is still there. Okay, so now you're a code cracker. Awesome. But what if you suspect a resistor has gone bad? How do you actually test it to see if it's still working right? Well, for that, you're going to need a multimeter. Now hang on. Before we touch a single thing, we need to talk about the #1 most important rule of electronics, safety. Seriously, always make sure the power to the circuit is completely, 100% off. You do not want to test a component on a live circuit. It's dangerous and you could easily fry your meter. Once you're sure the power is off, it's actually really easy.
The best way to do it is to take the resistor completely out of the circuit. That way you get a clean reading without interference from other parts. Just set your multimeter to the ohms mode, touch the probes to each end of the resistor, and see what number pops up on the screen. Then you just compare that number to what the color code says it should be.
And here's a little pro tip for you. If you put your meter on it and the screen just says OL for overload or shows infinite resistance, well, that's a dead resistor. It means it's failed and created a break in the circuit. Time to replace it. So, we've covered what they are, how to read the codes, even how to test them. But let's take a step back for a second. Why are these things so foundational? Why are they in literally everything electronic? Well, their job is so much bigger than just slowing down current. Sure, that's a big one, like protecting an LED from burning out. But they're also used to split a voltage into smaller, more useful levels, or to set up transistors so they work properly. I mean, the list just goes on and on. They are the true, unsung heroes of the circuit board.
And they can get pretty specialized too. Take something called a current sense resistor. It's a super precise, very low value resistor. Its whole job is to let a circuit measure exactly how much current is flowing through it. And that's absolutely critical for making things like your phone or an electric car as efficient as possible.
And there you have it. What started as just a tiny, mysterious component with some colorful stripes is now something you can actually decode, test, and understand. You speak a little bit more of the language of electronics now. So the real question is, with this new knowledge, what are you going to fix first?